Next presentation is algorithm development on a JupyterHub. So I guess before I begin with this, I'd like to just discuss a little bit about what I'll be presenting during this presentation and how it relates to what Joe Kennedy will be presenting tomorrow. You know, when we were asked to put on this workshop demonstrating how you can move your science workflows to the cloud, you know, we realized that there are a couple of different ways to think about this. So there's moving your development to the cloud, and then there's moving data processing to the cloud. And so those require different cloud architectures and different systems, and they really address different use cases. So today, what I'm going to be talking about, algorithm development in the cloud. I'll be focusing on the tools, and Dylan has already begun this. You know, talking about tools like Conda and GitHub, and then S3 buckets and things that in JupyterHubs, things that facilitate working together as a team with a team of developers working on a project together in the cloud in an organized way. And so that really centers around a JupyterHub, a managed JupyterHub, which ASF provides in the form of OpenSARLab. And then tomorrow, Joe will cover moving a completed, a completed algorithm that has been developed by a team in the cloud. When you've gotten to the point where the algorithm is hardened and you're ready to actually operationalize it and start producing lots of data with it, then you don't want to do that in a JupyterHub. That would be incredibly slow and pretty expensive. And so that really calls for a distributed cloud processing service, and that is what Hype is, what ASF's service Hype is for on-demand processing. And so tomorrow, Joe is going to demonstrate how you can take an algorithm that you've developed, possibly in a JupyterHub, in a notebook, and then use that to create a plugin for a distributed processing service. In this case, Hype. So, just to show you a little bit of what the differences in the cloud architecture are for these two use cases, just at a very high level. So here is what it might look like to develop code with a team of developers working in a JupyterHub. So here, this yellowish orange box represents an AWS account. And inside of the AWS account, we have a JupyterHub running. Oh,
I don't think you're sharing.
I'm not sharing. Oh, no. Okay. Well, luckily, I just got to the part with the picture. So the last slide was just words, and I probably don't need to go back. All right. Can you see the slides now?
Yes.
Great. Okay. So this is an architectural diagram. The yellowish or the orange box here represents an AWS account. Inside of the account is a JupyterHub that's running inside of a Kubernetes cluster. So that's this blue box. And so inside the Kubernetes cluster, there are multiple nodes. So each of these kind of rounded boxes represents a node. And a node runs on an EC2 instance. And so there is a hub node that controls all of the other nodes and handles all of the auto scaling and user management. And so then there are the individual server nodes. And so those can contain a single user pod, which is running a Docker image, running JupyterLab. Probably also has a Conda environment installed so that you can run a given set of notebooks. And so each of these nodes running on an EC2 can contain a single user pod or many. In the past, for OpenSARLab, we have used shared nodes, A lot of Jupyter hubs use shared nodes. We've as a means of saving costs and also if you have a shared node, it takes a while for these to start. So if you have a shared node, then and one user's already on there, and then another user comes along, the second user doesn't have to wait for that to start up. It's already pre-warmed, and they can just hop on. However, we have seen users cause conflicts for each other. So recently we've moved more towards a model of having a single pod per node, but that's really just a decision that a Jupyter hub can make for and set up differently on different hubs. So here you have multiple users. Each has their own environment. These environments are running on identical hardware. They can be running identical software environments, all shared with each other via Conda, and they are all working on a shared code base that lives in the GitHub repository, pushing code to this repository, and then merging their updates and pulling in updates as each member of the team makes them, and thereby developing this a project together in an organized way. And nothing is saved on one person's computer. If their computer crashes, all of the code is saved in the repository and accessible. Okay, and so the sort of the use case that this model fits is when you are working to develop a project and you need in these identical environments and you want to share updates easily. Now, what Joe's going to talk about tomorrow is requires a very different type of architecture in a cloud service provider. So here, once again, we have our AWS account. But you'll notice here, there's just a single user. So there could be any number of users connecting to these services, but they're not working together. This is just a single user who wants to order a bunch of data. And so they have an account on an on-demand processing service, in this case, Hype. And so they hop on Hype, they order, one or hundreds of processed products. And so, like right now, Hype provides radiometrically terrain-corrected data, interferograms, and auto-riff products. And so you order up a whole bunch of data, and then those jobs are, for each of those jobs that you've ordered, an EC2 instance is spun up that's running a Docker image that runs the code to process the data, and then saves the output data to a location somewhere, typically an S3 bucket, but it could really be anywhere, which is then accessible to the user. And so that's a very different type of cloud architecture. And so here is an example of the use case. So you've already developed and tested your algorithm, and now you just want to use an on-demand processing service to generate a bunch of data. And so that's what a distributed on-demand processing service provides. Okay, so generally, once again, just as a reminder, the same architectural diagram I just showed. When you're developing in the cloud, you want everybody to have access to the same hardware, the same software, and you want them to be working from a shared code base. And so those are the important aspects here. These are shared. This is all shared hardware. Each of these servers represents shared hardware. Each of these Conda environments represents shared software environment. And then, of course, the code that they're developing is shared in a GitHub repository. And so a typical workflow that you might see is, hopping on a JupyterHub server, cloning in a repository that somebody on your team has created, then creating a branch in which to put your updates. If you're on a JupyterHub adjacent to the data set that you're working with, you're either probably going to be streaming that data into memory or downloading it. Then you're going to work on your code, pull in new updates as colleagues submit them, update software environments as you expand your code and require additional packages, share all of your updates with your team, submit pull requests to merge your updates into the main branch of the repository, and then review your colleagues' pull requests to merge their updates into the main branch as well. And so now I'll give a little demo of what that can look like. So there is some optional homework. So Joe, like I mentioned, tomorrow Joe is going to demonstrate how to take an algorithm that you've developed in a notebook and convert that into a Hype plugin. And so if you'd like to follow along, in order to prepare and make sure that you have all of the, to make sure that you have the notebook and the environment that will run that notebook, you should once again clone the workshop repository, build the Conda environment, and then just run through the NISAR ATBD Wetlands notebook that I'm going to be showing here shortly, just to familiarize yourself with it. You don't need to make any changes to it. Just have that in place with the software environment to run it, and you should be ready to pick up with Joe tomorrow. All right, now I'll hop back over to OpenSARLab. Just going to shut these. So am I still sharing my whole screen, or are you still seeing the slideshow?
Yes, we can see OSL now.
Okay, great. Okay. So I am going to show the NISAR ATBD Wetlands notebook here, but first I want to just pick up where Dylan left off. So Dylan made a new repository in which he added this notebook and an environment to. So I'm just going to pretend that I'm working on this project with him, and that there is this new repo that he's told me about. So I'm going to head back over to our GitHub organization, and I see that there is this new Wetlands notebook repo here. So I'm going to open this. I want to push and pull to this, and I do have my SSH keys set up. So I'm going to use the SSH link here. This is really just a demonstration. This is not something you need to follow along with for the workshop. I'm just showing you a general workflow of what it looks like to work alongside somebody else in a JupyterHub. If you do want to clone this, you're welcome to. It's a public repo. Just be aware that you won't have permissions to push any changes back to the repo. You'll just be able to clone it. So you would probably want to use the HTTPS link if you did that. But since I'm going to be pushing to it, I do want to use the SSH link. Now I'll head back here, and I'm just going to open up a terminal. I'm going to go to my home directory. And I'm going to clone in this repository. I hit the same issue that Dylan hit earlier. So it says I have an overly accessible SSH key file here. So I'm just going to update. I'm just going to tighten up the permissions on this a little bit. So I'm going to copy this path. This is just telling me this is the file that I need to adjust the permissions on. And I'm just going to go chmod 600, and then paste that path in. And now I can go ahead and clone that notebook, or that repo rips. And so if I come back here to my file browser and I go to my home directory, I now see that I have this Wetlands notebook here, and that has the environment that Dylan added there, and the notebook as well. And so Dylan and I had this idea that we would demonstrate what it looks like, how things can potentially go a little bit wrong when you're working with somebody on a repo. So right now, if I run git status on this, it says I'm not in a repo because I just cloned the repo, but then I didn't CD into it. So first I have to go into CD into Wetlands notebook. Okay, and now if I run.
Sorry to interrupt, Alex, but we've got a request to please increase the size of the text.
I can make it a little larger.
Thank you.
Thanks, Sarge. All right. Okay, so I just ran git status, and you can see that I am on the master branch and that I'm up to date with origin master. And so now Dylan and I are both going to make a change to this file at the same time. And so I've cloned this, so I have the repo as it existed when Dylan pushed it during his presentation. But now, Dylan, if you could go in and add maybe the ASF search package here to the top, like this. So if you had ASF search as the top dependency there, and then push it, push that change to master, and then let me know, then I'll go in and I'll add a different dependency. And then when I try to push it, it should yell at me and tell me that I need to pull in updates and then probably also create a merge conflict that we can resolve.
Yeah, I think that should be ready now.
Awesome. Okay. So Dylan just made a change here on this repo. So if I refresh the screen, okay, yes, now you can see that ASF search is at the top of the environment YAML, but back in my copy that I pulled before he made that update, it does not include ASF search. And now let's say I was unaware that he went and made that and pushed that change. And I came along and I said, I'm going to install, I think we need another package here, and it's OpenSARLab lib. So I think we need to add this package to the top of our environment. And so I'm going to save this. And now I'm going to add that notebook. Well, actually, let me just run git status because it should tell me that I'm not. Yeah, okay. Okay, so it says I'm up to date with origin master. I'm on the master branch, but I haven't done a pull yet. So it's unaware of the changes that Dylan just made. However, it does recognize that I made a change to the environment YAML because I just added that OpenSARLab lib package there. So I'm going to say git add. Oops. Git add in the file name. And now if I do a git status, it shows that this file is staged for commit. So Dylan showed how you can do this all in one easy command. So I'm just showing you the longer way because there are often more than one way to do things with these tools. So I've added the file, but now I need to commit it. So I'm going to do git commit with a -m for message. So Dylan had done the AM, which adds and creates the commit all at once. So I'm going to say add OpenSARLab to environment YAML. Okay, so now I've made my commit. And so now what would happen if I tried to push that back to the master branch? Let's just see. So I'll say git push origin master. Oh no, it rejected it. So it says updates were rejected because the remote contains work that you do not have locally. That would be the update that Dylan made. This is usually caused by another repository pushing to the same ref. So and then it gives me this little hint. You probably have to do a git pull. So now I'll say, okay, somebody made a change. I got to pull that in before Git will allow me to push my change. So I'll say git pull origin master. Oh no, we have divergent branches. So something's wrong. Dylan made a change. I made a change. And so we need to specify how we're going to deal with this. So you'll see that it gives you a few different options. I'm not going to take a deep dive into what these different options are, but I am going to go with the default option here. It's really good about kind of leading you down the correct path to resolve your problem. When it gives you a scary warning like this, it will often tell you the reason and often the solution as well. So okay. So now I will try doing a git pull again. Okay, so now it let me pull it let me do a pull, but it noticed that there is a merge conflict. And so automatic merging failed. And it's telling me that I have to fix the conflicts and then commit the result. And so now if you go and open up the file that's the source of the conflict, you'll see that Git has added some additional lines here. And so it sort of encapsulates the conflict here between these two lines, that one that starts with head and then one that ends with a commit hash here. And so you'll see that saying, okay, two people are trying to push to this repo, and they've both edited the exact same line in different ways. And so, you know, poor GitHub doesn't know what to do. And so it wants you to figure out what you actually want in this repository. And so if this were to happen, then it's probably a sign that you want to talk to the person that you're collaborating with and say, you know, hey, Dylan, so it looks like you're trying to add ASF search and I'm trying to add OpenSARLab lib. And then maybe discuss why were you trying to do that, and then come to a conclusion about, oh, okay, so which do we want, both of these things or just one or the other? And so I think in this case, I'm just going to go with Dylan's change. We're going to include ASF search, and I'm going to decide that my OpenSARLab lib addition here was a mistake. We don't really need that. So I'm just going to delete that, and I'm going to delete all of the lines that get added. There, I'm going to delete that. I'm going to save the file. Now I'll come and I'll run git status again, and it notices that environment YAML has been updated. So once again, I'm going to git add my environment YAML. And I'm going to say revert to Dylan's change. Keep ASF search. It's good to write. You know, it's really easy to say when you're writing these commit messages to just say something like, you know, bug fix or update, but it is generally helpful when you're trying to look back through history and figure out when some change was made. It's nice to have these handy commit messages. So it's tempting sometimes to just put something in very quickly, but if it really is a good idea to include useful commit messages. So so now it let me commit that, and now it should let me Push this. Yes. Okay. And so now, having resolved the conflict, I was able to make my commit and push to master. And so now if I come back here and back and take a look at this, you can see that in the master branch, it doesn't contain OpenSARLab lib anymore. It just has the ASF search that Dylan added. Okay, and so so one thing that that Dylan and I just did that kind of is I guess a Git anti-pattern is that we were both just pushing to master. We were both making our updates and pushing to master. What we should have been doing was creating branches and ideally not just merging those branches to the default branch ourselves, but submitting pull requests. And so actually, Dylan, didn't you have a pull request on here? Yes. Okay, yeah, so here is a pull request that Dylan made earlier. So so I can go ahead and add my review. Okay, so if I review the change, I can leave a comment and say looks good in this case. There's not much to comment there. Then I can approve it. If there were some, you know, if I noticed something and something off, I could request changes, and then that would notify Dylan that maybe he should think about making an update before we complete the pull request. So then I can submit my review. And now you'll see that this has an approval, and I could either go ahead and merge this pull request myself, or I could leave it up to Dylan to do that. That's generally, you know, when you work on a team, different teams handle it different ways. So you just have to decide amongst your colleagues whether you want to merge each other's pull requests or just review and leave it up to the person who created the pull request to approve or to actually do the merge. Okay, so back in OpenSARLab here, we've now successfully, you know, handled that merge conflict, and the environment YAML is updated with ASF search. But now, let's say I wanted to add the pinned environment YAML, because it's nice to have a pinned YAML. If you're working on the same operating system as your colleagues, which in general, if you're in a JupyterHub, you probably are, a pinned YAML will build much faster because the package resolver is able to run incomplete on its first attempt. It doesn't have to try a bunch of additional packages. It tries the exact pinned versions and discovers that none of them conflict with each other. And so those pinned environments tend to build faster and tend to be a little bit more stable. An unpinned YAML, you know, at any moment, any one of these packages could push an update that caused a dependency conflict with another package and then require debugging. Whereas if you have everything pinned, then, and you know that it worked once, then it's probably going to work into the future unless something unusual happens, like a pinned package is actually pulled from the repository, which does happen on occasion. Okay, so I'll head back over to the NISAR Early Adopters Workshop Jupyter book, where we do have a pinned environment. And so I'm going to copy this into the Wetlands directory here. Okay, so now I've got the pinned YAML, which has all of these specifically pinned versions. But instead of just pushing this to the master branch, I am going to create a feature branch and submit a pull request. So I'm going to say git checkout the B option. And so this will, this is another kind of one of those 2-for-1 Git commands. So if you have an existing branch, then git checkout in the branch name is how you would check it out. But if you want to create a branch and check it out at the same time, then you can just use the -B argument for the which is the branch argument for with the git checkout command. So I'm going to say git checkout feature, and then I'll say pinned env. And so now you can see that I've switched to a new branch called feature pinned env. This is a local branch. This is not a remote branch yet. So if I come over here, just having created that branch in on my JupyterHub server did not create a new branch here. So even if I refresh this screen and I look at the branches, all I've got is the master and develop branch. I do not have the feature branch that I just created yet. But now I'm in my my local feature pinned env branch here. And so if I say git status, then it will show that I have this untracked pinned environment YAML. So I'm going to add that. And then commit. And then when I push, I'm not going to push to the master branch. I'm going to push to this feature pinned env branch. Okay, and so now it says that it's created a new branch in GitHub at this repository. And so it has pushed my local feature pinned env branch to the repo as a remote feature pinned env branch. And so now if I come back here and I refresh the screen, you'll see that there is this feature pinned env branch here. And oftentimes when you push a new branch, Git assumes that you may want to submit a pull request. So it gives you this handy little button that will let you jump into creating a pull request. However, if that is not present, if a half an hour has gone by and this little button is no longer available, you can just create a branch or a pull request by going to the pull request tab up here and then say new pull request. And then you have to declare which branch you're pushing to which branch. You don't always have to merge one branch into the default branch for a repo. You could be merging one feature branch into another feature branch. You can merge any branch into any other branch. Although typically you are merging a feature branch or a bug branch into the master branch or the main branch, whatever the default branch is. And so here you can see that there's been one commit and one file changed. And so this is all green because the entire file is new. And so I'm just going to say create pull request. And it's pretty straightforward. If I'd made a bunch of changes, it can be nice to put in a nice list of all of the things that you've done in this pull request. In this case, all I did was add this file, so I'm not going to bother putting anything here. I'm just going to leave it described in the title. And so then I will create I guess I can make a label. I will say it's an enhancement because I'm adding a pinned YAML. And then I'll create the pull request. And then I can go and request a review from anybody in my org. And so in this case, I'll requested review from Dylan. All right, and so that is that's how you how you set up a feature branch, and that's the general flow of setting up a feature branch and submitting a pull request, and that really prevents you from creating conflicts with your colleagues, and it helps you manage your the flow of your work in an organized way, and working in GitHub protects you from losing your files, your local files, if something were to happen to your computer. Okay, so the last thing that I would like to show is just a run through of the Wetlands notebook. So you'll notice I clicked the JB button here, and it recognized that I am not in a Jupyter book. I'm just in a normal GitHub repository here that does not have a Jupyter book in it. So I will navigate back to the NISAR Early Adopters workshop book. Then I can click the JB button and come down here to the notebook, NISAR ATBD for classification of wetland inundation extent notebook. And so here you can just run through this notebook. And so here, I'll put back here. Okay, so this cell here creates the paths. So this has just created a bunch of empty directories in which we'll store our data. This cell here searches for the data in an S3 bucket. So these the sample GCove products that we're going to be using here. So these are excuse me, NISAR sample data products, GCove products. These are stored in the NISAR CalVal public West 2 bucket, which is a public JPL bucket. We don't have control over that at ASF, and I was a little bit worried that we would have very bad luck in those files would be deleted before the workshop. So just as a backup, I also saved it in an ASF bucket with the same prefix. So if for some reason the JPL bucket stops working, we have this backup ASF bucket here as well, which I can comment out for the moment because I believe that the data still are, yes, the data still are findable in the JPL bucket. And so that was just the search. And now I will download the data. Oh, one other thing that I should point out here, which I think I briefly mentioned in the S3 presentation, but forgot to show, is that some buckets are set up so that the requester of the data, their AWS account pays for the data. And so if that is the case, you have to have your credentials configured because, of course, it has to AWS has to know which account to charge those fees to. And then you also have to use the requester payer argument and with the requester option defined there. And so any charges associated with downloading this data will get charged to the ASF AWS account, not to the JPL AWS account holding that bucket. Okay, so for now, these data are stored just in these buckets. However, ASF will eventually host NISAR data, and so this is a calibration and validation notebook, and that you'll be able to run on actual NISAR data. And so when there is NISAR data, these commented out cells here provide a couple demonstrations of different ways that you could access those data. Of course, these will not work now because there is no NISAR data to access this way. Okay, now we're just grabbing the paths to the data that we've downloaded. Those are in these G-code folders here, or in the G-code folder here. Okay, so it's just setting up the time series. Grabbing some of the metadata. So here we can see the raster size, resolution. These are the bounds in UTM, and then this is the projection. This is, so it's probably an EPSG 32615. And this is just a plot from the USGS weather water level gauge on the in the location where the data are collected on the dates of the acquisitions. And so each of these stars represents one of the dates of our acquisition scenes. Reading in the imagery. And then there are some optional both spatial rolling average and a temporal rolling average. We can just run these as they were set. Okay, so it looks like this was set to 1. Okay, and so this is executing spatial averaging. Looks like to put it on a 5x5 resolution, and we can hop down. Okay, so these are calculating normalization factors, I think, or correction factors, it looks like. Sometimes these plots take a minute to, to render. There we go. Calculate the means. Excuse me. So this plot, when it finishes, will show us change relative to the mean values. One other thing to point out about notebooks is that while a code cell is running, it will have an asterisk in the brackets here, and then once it completes processing, it inserts a number which indicates the order in which it was run. So here, this was the 14th code cell to run. This was the 15th code cell to run. Okay, now we're getting to the classification section. And so it looks like this is going to break it down into 5 different classifications. Okay. So what was that 5th classification? Oh, no data. Okay. So really 4 classifications and no data. All right, so here we can see the inundated vegetation in yellow, or in kind of mustardy color yellow, and then in brighter yellow. It's a little hard to distinguish on the plot here. is the, oh, so this was from the HH, inundated vegetation, and then this is from HHHV, bright yellow, and then green is no water, and blue is open water. Okay, and then this is showing the change in open water in inundated areas and non-inundated areas through our very short time series here. All right, and I believe this is showing us when these changes occurred. All right, and so I believe that the output products were right here. And so these are saved in, let's see, Mississippi, Vicksburg. Ah, right here. And so these would be the output products that will be generated by the Hike plugin when this notebook is converted into a Hike plugin tomorrow. So so to prepare for tomorrow, really all you need to do is just clone in this repository, build the environment, and just run through the notebook to familiarize yourself with it.